Hi students, welcome back to the second part of the chemical preservation of foods. We had previously mentioned about the different types of preservatives, the class 1 as well as the class 2 preservatives, and among them include the natural counterparts of salt and sugar, etc. Many natural components are also there, and you can also have weak organic acids or acidulants both in class 1 as well as the class 2 preservatives. These could arise because if they are coming from a natural source, we would include them as a class 1 preservative, and if they come under a unnatural or a man-made source, we refer to them as a class 2. Now, among the weak organic acids or the acidulants, you have members such as acetic acid, lactic acid, sorbic acid and a salt, benzoic acid and a salt, propionic acid and a salt, malic acid, tartaric acid, citric acid and ascorbic acid. Among the inorganic salts, we have the nitrites, nitrates, chlorine, iodine, hydrogen peroxide, phosphoric acid as well as borax, and the gaseous members includes sulfur dioxide, sulfides, carbon dioxide and ethylene and propylene oxides. In addition to this, you can also have any other preservatives such as the antioxidants, oils and spices. Now, if you go to look at this particular list, acetic acid is quite familiar to us. Acetic acid is vinegar, and lactic acid is a one which has been produced by what? Just recollect it, by the lactobacillus. In the curd, we do find lactic acid. Okay, and coming to tartaric acid. Tartaric acid is mainly been found in the tamarind. Okay, then you have ascorbic acid or the vitamin C, which has been found in the lime. Citric acid is a very good industrially relevant enzyme which has been found in the food. Okay, and coming to the remaining members, you have antioxidants. Antioxidants are quite found in almost most of the fruits, which will prevent the oxidative stress. Oils and spices. Oils and spices are quite familiar things which we use in our daily food. Even in pickles, to overcome them from food spoilage, we would put an overlay or we would overlay the pickles with some oil. And the inclusion of spices in the food, as we all know, would help us to preserve the food from various microbial spoilages. Now, coming to some of the preservatives that we use, sodium chloride is quite familiar, the common salt, and the antimicrobial action of it mainly is happening because of it lowers the water activity of the food product, and this creates an unfavorable condition for the microbial growth. At a very high concentration, sodium chloride also has bacteriostatic action, and 10% NaCl will inhibit the growth of most of the bacteria. And delaying action upon microorganisms creates a dehydration of the microbial cell by osmosis, and this would result in the plasmosis of the cell, and the cell would get lysed down. Then the reduction in the solubility of oxygen in water would decrease the oxygen level in the food and reduce the growth of the aerobic microbes. Now, it is more effective against bacteria and mold compared to the yeast. And as we all know, this is the most traditional method of food preservation, and you can see food in either the salted fishes, butter, cheese, etc. We would have salt as a common ingredient, but they all do the same role of inhibiting the microbial growth, microbial activity while reducing the water activity. So let's go into the next natural component. Sucrose or sugar. It is more effective against the bacteria and the mold compared to the yeast, and antimicrobial action arises from the lowering of the water activity of the food product, and this creates dehydration of the microbial cell by osmosis, resulting in the plasmosis of the cell. And the food products which we all know which have been preserved by using sugar, it includes the jams, jelly, squash, dairy products, etc. Coming to the weak acidulants, these are organic acids which will influence the pH and therefore the environment of the microorganism. In solution, they exist in a pH dependent equilibrium between the undissociated and the dissociated state, and the undissociated molecule is freely permeable across the plasma membrane and thus able to enter the cell. The induction of an energetically expensive stress response will result, and that will attempt to restore the homeostasis. This results in the reduction of the available energy pools which have been available for growth and other essential metabolic functions. So when the acid is being present, what happens? There would be a stress on the cell, because what happens? The acid pierces, becomes permeable to the plasma membrane, and there would be an energy imbalance. What happens? Trying to overcome this stress, the energy which was needed for the growth and other essential metabolic functions of the microorganisms becomes limited. Now, the common acids that we have is acetic acid, vinegar. It is a product of lactic acid fermentation. The preservation action is at identical pH levels is greater than that of lactic acid. And even if you consider, that point is a thing that even at same pHs, if you consider lactic acid and acetic acid, the preservation action of acetic acid has been found to be greater than that of lactic acid. And the antimicrobial activity increases as the pH decreases. This is usually used to preserve pickles from bread and other baked foods, and also to prevent the ropiness and the growth of molds. And they are not very effective against yeasts. So you know about acetic acid. Acetic acid is a common vinegar that we use, and we have already spoken the preservative role of vinegar in various foods. Now coming to lactic acid. The lactic acid is something which is being produced by the probiotic microbial organisms, and it is a main product of many food fermentations. Example in the case of sauerkrauts and pickles. This acid produces a decrease of the pH to levels unfavorable for the growth of spoilage causing organisms, such as the putrefactive anaerobes as well as the butyric acid producing bacteria. So when the pH becomes low, these microbes, that is the putrefactive anaerobes as well as the butyric acid producing bacteria, find it an unfavorable environment for their growth, and their growth is being inhibited. But it is not very effective against the yeast and the molds. Coming to the next one is the benzoic acid. It occurs in the form of a sodium salt also, and the sodium salt has been found to be more soluble than the free form of benzoic acid, and it constitutes one of the most common chemical food preservatives. Here, yeasts are inhibited to a greater extent than the molds and the bacteria, and it has an optimum pH of about 2.5 to 4. Various acidic foods such as fruit juices, carbonated beverages, syrups, jams, jellies, sauerkraut, pickles and fruit cakes all can contain benzoic acid as a chemical preservative. And the antimicrobial activity of benzoic acid is achieved mainly by the inhibitions of the enzymatic system of the microbial cells, affecting their acetic acid metabolism, citric acid cycle, as well as their oxidative phosphorylation. Coming to sorbic acid. Sorbic acid and its salts like calcium, potassium and sodium salts, they are quite effective antimicrobial agents against yeast and molds as well as bacteria. They are also been found to be less effective against bacteria, and they have an upper pH limit of activity around 6 to 6.5. So at pHs beyond that, these are not being found to be very much active, and you can also find them in carbonated beverages, salad dressings, tomato products, jams, jellies, syrups, candy, chocolate syrups, cheese, sausages, smoked fish, fruit juices, etc. So you should remember that, of course, there are natural methods to preserve the food, but the ready-to-eat foods which we found in our market are being found to are preserved, and they are being made edible free from spoilage. They are made free from spoilage by the action of various chemical preservatives like this. Then you have something else called the sulfur dioxide. It's a gas, and it is one of the oldest antimicrobial agents. It is a colorless, non-flammable gaseous compound or a liquid under pressure with a suffocating pungent odor. And when this is being dissolved in the water of the food, it yields sulfurous acid and its ions. owing to its solubility in water. And the sulfide salts such as sodium sulfide, sodium bisulfide, potassium sulfide, potassium bisulfide, these are all can be used as preservatives. And when the sulfurous acid is being formed, what happens? It acts as an active antimicrobial substances. And at a very low pH levels, sulfur dioxide is a very good antimicrobial agent. And bacteria are generally more sensitive to inhibition than the yeast and the malts. And in various fruit products, we are using the sulfur dioxide. And coming to, there is a limit up to which the different chemical preservatives can be used. It has been specified by FDA. And coming to lactic acid and citric acid and acetic acid, as we know, these are all natural methods. We do not have any limit for the acceptable daily intake of these, because most of them, what happens if you have citric acid, acetic acid or something, there is no limit about how much you can take. Coming to the other, that is a class 2 food preservatives like sodium benzoate, sodium diacetate, sodium propionate, potassium sorbate, etc. There are certain limits beyond which they are not allowed to be taken in your body. Okay, and so now that is a milligrams per kg body weight. That is a acceptable daily intake which has been given here. And so the level at which they are being used in a food should be very less. See, a 15 milligram per kg body weight is only permitted now in the case of sodium diacetate, but the percentage of that used in the food is being found to be 0.3 to 0.5%. So if you use the chemical preservative beyond this level in the food, that would be found to be toxic towards the person who is consuming it. So I guess this is clear to you. Then of course we have some other chemical preservatives also which I have not mentioned in this. Now you have gases. Okay, we have mentioned here. What was that? Ethylene, which was the gas. You have ethylene and ethylene oxides and all that, as well as carbon dioxide. These are all being used for food preservative. Now in the case of carbon dioxide, you are quite evident that is to increase the shelf life of the meat. We could use carbon dioxide in the storage condition so that it will inhibit the growth of microbial spoilaging organisms. And ethylene oxide is a very good gas food preservative to preserve various spices and all that. So I guess this is clear to you. And with this, we come to an end of chemical preservatives. Thank you for your attention.